Hello, this is Krystopher Pinnock of Temple University's Space Management Department. I would like to welcome you to my topography tutorial. Throughout this tutorial, we will touch on ArcGIS, AutoCAD, topography alignment, extruding, and organization of cut files.
Okay, so in this tutorial, I will delve into the development of the campus topography and how we manipulate these contours to prepare the laser cut files. Throughout this tutorial, we will use Rhino, AutoCAD, and give a quick mention about ArcGIS. Now to begin, as you can see, we have the topography contours in AutoCAD taken from ArcGIS, but they are a bit hard to read at the moment. Over time, we clean up all these lines to make them suitable for the desired topography requirements. In order to change the height distances of the contour lines, you want to go into a right or left view. Here you can see the contour lines from a right perspective. This view makes it easier to manipulate and change the height distances of each contour line. Now that we have our contour lines organized and spread out into our desired height requirements, what we want to do is take these contour lines and extrude them into solids. For example, take one contour line and through the extrude command, we can pull this polyline, let's say 200 feet, and then we have our contour line's perimeter. Then with the cap command, we can close it. Now we have one solid contour line. Continue this process. Extrude, put in the distance, and cap, and you now have different layers for your contour. We now have each respective contour layer extruded, and what we want to do is put these contour layers on specific layers so that they can be easily distinguished. It also helps to make them different colors so that they can be seen easier. And here we have our final topography. We can go into the right view and actually see how these contours stack up. Now that we have the extrusion sorted out, we can begin with the topography cut files. What we want to do is revert back to our simplified contour lines so that we can make the laser cut file. Next, what we want to do is we take the campus grid or whatever grid that you create and place them on the same plane as the contour lines. These respective grids or boxes will become the laser cut files that we create with the respective contour lines within them. Notice how each contour line is still one whole. And for our laser cut file, we'll need each contour line sectioned off within its boundary box. In order to do this, we use the trim command. After typing it in, we'll need to select the respective boundary box. This sort of acts like, I guess, a scissor in a sense. And then we select which parts we want to trim off. Now that we have our piece sectioned off, we can begin the laser cut file. We can alter each polyline either by blue or red. Blue notifying a score, or red for cutting. Next, we separate each contour level into different pieces so that it can be cut out in the laser cutter. Each piece is then to be layered. Note, the laser cutter dimensions are 18 by 32, so be sure whatever material being used falls between this dimension. Organize all cut pieces so that they can fit into each respective material boundary in order to save on resources, as you see here. Follow the topography grid in order to distinguish the amount of sheets required.
This concludes my tutorial. I hope that it was insightful. If there are any questions in regard to the steps of this tutorial, please feel free to contact Space Management at temple.edu. Thank you again.